All right, so in this video, we're going to go through sample question 98 from the Society of Actuaries ExamP list of sample questions. The question reads, let x1, x2, x3 be a random sample from a discrete distribution with the following probability function. Determine the moment generating function, mt, of y equal to x1, x2, x3, the product of the three discrete distributions, the random sample from discrete distributions. So, what are we looking for? Moment generating function can be defined as follows. So m of t is equal to the expected value of e raised to the yt. All right, so this is going to be equal to the sum of each item that t can take on times the probability that it takes on that item. All right, so let me expand this out. Equal to e raised to the, y1 t multiplied by the probability that this takes on the value y1, and, so on, how many ever situations we have. So let's actually figure out the distribution for y. So y is going to have the following distribution. I'll just say probability of y is equal to the following. Okay, now we know y is equal to x1, x2, x3. All right, now x1, x2, x3, they're all identical, and they can either take on 0 or 1. The probability that they take on any other number is 0. All right, so if we're thinking about all these different possibilities, y can either take on 0, right? If any one of these numbers ends up being 0, y is going to be 0 because y is the product of all three. If all of them are 1, then y will take on 1. There's no other option for y. So our possibilities are y equaling 0 and y equaling 1. Now we have to figure out the probabilities of these. So the probability that it equals 0 would be if any one of these equals 0. And it's not just all of them being 0. You could have any mix combination. And that looks like a binomial distribution. You could use that to figure out what this actual probability is. However, there's an easier way. Let's skip this for now and look at y equals 1. The only situation where y equals 1 is where x1, x2, x3 are all 1. Okay, now what's the probability that x1 and x2 and x3 are all 1? Well, that should just be their product. So here it's going to be 2 over 3, right? The probability of each to the third, which is 8 over 27. And let's grab my calculator. I actually don't need it for this. Since all the probabilities should add up to 1, 1 minus 8 over 27, 27 minus 8 is 19, right? 19 over 27 should be the probability that y equals 0. All right, so that lets us avoid doing anything somewhat messy. So calculating the moment generating function, m of t, well, that's equal to, like what I mentioned before, the expected value of e to the y multiplied by t, which is equal to e raised to one value that y can take on is 0 times t, multiplied by 19 over 27, the probability of y taking on 0, plus e raised to the 1 times t, multiplied by the probability that y takes on 1, which is 8 over 27. And obviously this should be 1, so that's equal to 19 over 27 plus, and obviously this is just going to be e to the t times 8 over 27, so 8 over 27 multiplied by e raised to the t. And that very clearly lines up with answer just A. So not at all a very difficult problem, pretty straightforward, right? So let's look at what they're giving us. We're asked to find a moment generating function. We should know this, right? The moment generating function is equal to the expected value of e to, whatever we're trying to find the moment generating function of, multiplied by t. And after that is just knowing how to calculate an expected value and knowing how to define a new probability distribution, okay? If there are any questions on this, leave it down in the comments. I'll answer it to the best of my abilities. If you have a need to see any more of these problems worked out, I got a playlist. And if this video helped you out, hit the like button, subscribe, because that totally helps me out. But other than that, I hope this helped. Thanks for watching.